The German tank commander could not understand what he was seeing. On the morning of February 20th, 1943, north of the Kasserine Pass in Tunisia, 5 American Sherman tanks moved through dust, smoke, and broken ground as if they shared a single mind. They were scattered across a rugged valley, separated by folds of earth and rocky ridges. There was no way they could see each other. No flags waving from turrets, no flares arcing into the sky, no messengers racing between vehicles. And yet, every time his Panzer IV edged forward, one of those Shermans shifted to cover a new angle. When he tried to pull back, another appeared on his flank as if it had been waiting there all along. To the German crews trained in the proud traditions of armored warfare, it felt almost supernatural. Tanks were supposed to move in rigid formations, responding to visual signals or prearranged plans. Here, however, individual Shermans broke, reformed, and reacted in real time, coordinating with a precision that Wehrmacht doctrine claimed was impossible without line of sight. Inside those American tanks, the reality was far less mystical and far more revolutionary. It was happening in the invisible space between them, in narrow bands of radio frequency, in vibrations of electromagnetic energy that the Germans could not see, could not touch, and, crucially, could not match. While the German commander fought his battle almost alone, shouting over engine noise and static, the Sherman crews were listening to something else. Calm, clear voices carried by a new kind of radio. Voices that turned confusion into coordination, chaos into control. World War II is often remembered in terms of steel and fire, armor thickness, gun calibers, explosive charges, and the sheer weight of industrial output. But in North Africa, Italy, France, and finally Germany itself, another contest was being fought in silence. It was a struggle not for higher velocities or thicker armor plates, but for something far more intangible: the ability to communicate, to coordinate, and to think as a team. For German crews, radio was a powerful tool, but also a rare one. Many tanks carried receivers only. They could listen, but not speak. When command vehicles were lost, entire platoons could become mute and directionless. For American crews, something very different was emerging. Every Sherman tank was becoming part of an invisible web, connected by a new generation of frequency modulation radios. These were not simply improved devices. They represented a completely different philosophy of warfare. This is the story of how those radios, compact, humming, 181-pound boxes, bolted into the steel belly of the Sherman, quietly reshaped the battlefield. A story of engineers in white lab coats and crews in oil-stained uniforms, of voices cutting through static, of veterans who would one day remember not only the sound of engines and tracks, but the comfort of a familiar voice arriving through headphones in their darkest moments. The transformation began long before the Shermans rolled into combat. On July 22, 1941, while German armored spearheads pushed deep into the Soviet Union, the United States Army made a decision that would quietly change the nature of armored warfare. It standardized a family of radio sets for its medium tanks, the SCR-508, SCR-528, and SCR-538. These sets were more than just equipment. They were a commitment, an insistence that every tank, not just the command vehicles, would have the ability to speak and to listen. Far from the front lines, in a factory belonging to the Galvin Manufacturing Company, better known to history as Motorola, engineers wrestled with a challenge that seemed almost impossible at the time. how to make cutting-edge frequency modulation technology rugged enough to survive inside a tank. The environment inside an armored vehicle was a nightmare for sensitive electronics. Violent vibrations, extreme temperatures, dust, oil, and the constant roar of the engine created a hostile world for delicate circuits and crystal oscillators. Yet within this unforgiving space, the team led by Daniel E. Noble and principal RF engineer Henryk Magnowski built something extraordinary. Their creation weighed 181 pounds and turned every Sherman into a node in what was, in effect, the world's first fully networked armored force. At the heart of this system sat the BC-604 transmitter, a compact powerhouse generating 25 watts of output, more than double the typical 10-watt German FUG-5 sets. Operating in the 20.0 to 27.9 MHz range, it offered 10 preset channels with crystal control stability, allowing crews to switch smoothly between frequencies without hunting for the right spot on a dial. Beside it, dual BC-603 receivers gave commanders a remarkable advantage. They could monitor two nets at once, one ear on their platoon or company, another on higher-level command. Orders could flow down, reports could flow up, and the tank remained fully engaged in both conversations. What truly set these systems apart, however, was not just power or flexibility. It was the use of Edwin Armstrong's frequency modulation, FM technology licensed to the military and adapted to the brutal realities of armored warfare. Where traditional amplitude modulation radios, like most German sets, picked up every electrical discharge as noise, FM worked differently. It filtered out much of the static and interference that plagued battlefields filled with engines, spark plugs, and electrical motors. In practical terms, that meant something simple but priceless. Voices stayed clear when everything else turned to chaos. In moments when decisions had to be made in seconds, clarity meant survival. While American engineers refined their FM sets, German crews entered the war with equipment that, on paper, was still impressive. The FUG-5 radio, operating in the 27.0 to 33.3 MHz range, was considered state-of-the-art in the late 1930s. But battlefield reality in the 1940s was merciless. On the move, a German tank's 10-watt transmitter often struggled to reach beyond a kilometer or two. Every spark from the ignition system, every electric motor, every jolt of the tracks created interference that amplitude modulation simply could not ignore. Voices dissolved into static at the very moment they were most needed. Worse still, radios were not universal. A typical German platoon of 5 tanks might have only 1 or 2 vehicles equipped with full transceivers, sets that could both transmit and receive. The rest carried receivers only. They could hear orders, but they could not report danger, request support, or warn others about threats. If the command tank, easily recognized by its multiple antennas, was lost in the fighting, the entire platoon could instantly lose its ability to coordinate. In those moments, German tanks became powerful but isolated machines, each crew fighting its own small war inside a much larger clash of steel. The North African campaign would be the first great proving ground for this invisible technological duel. On November 8, 1942, Operation Torch brought American forces to the shores of Morocco and Algeria. Among the equipment rolling off landing ships were Sherman tanks already fitted with SCR-508 radios. Facing them were some of the most experienced armored troops in the world. elements of the Africa Corps. These veterans had honed their skills against British units across deserts and rocky plains. They understood maneuver, timing, and the importance of communication. Yet they were about to encounter something new, an enemy whose tanks did not just follow a leader, but talked to each other continuously. In the months that followed, from the initial landings to the brutal fighting around Kasserine, German signals intelligence units began to notice an unsettling pattern. When they intercepted American transmissions, the clarity was striking. Even under intense engine noise and heavy artillery fire, American voices remained remarkably easy to understand. At the time, German analysts believed this was largely due to discipline and training. They suspected well-rehearsed procedures and strict radio procedures. Few realized they were listening not just to disciplined operators, but to a different kind of technology altogether. The Battle of Kasserine Pass, fought between February 14th and 24th, 1943, is often remembered as a painful lesson for American forces. Tactically, the Germans achieved several notable successes. But beneath the surface of that struggle, something else was happening, something that would matter far more in the long run. American armored units, still inexperienced and often scattered, discovered that their radios could do more than just pass orders down from headquarters. Tank crews who had never met before, belonging to different units, found that they could coordinate over distances of up to 50 miles. An isolated tank, pinned behind a ridge, could call for help. A crew that spotted enemy armor moving through a gap could warn others before the threat materialized. Artillery could be guided onto targets by tanks that were nowhere near the front of the formation. In after-action reports, German observers remarked upon this strange ability. American tanks, they said, seemed able to coordinate without visible signals, even when terrain cut them off from one another. What they were seeing was the birth of something that, decades later, would be called network-centric warfare. For the crews living it, it felt simpler and more personal. When a calm voice answered through the headphones, when a distant unit confirmed, "We see it too," the desert suddenly felt a little less vast, a little less lonely. By 1943, American armor was moving from North Africa into Italy, a land of mountains, narrow valleys, and twisting roads that should have reduced radio effectiveness. In theory, this terrain favored visual signals and prearranged plans. Steep ridgelines blocked direct paths for radio waves. Narrow passes created zones of reflection and distortion. Many expected radio communication to become unreliable or even useless. Instead, FM technology once again proved its worth. Where amplitude modulation struggled with multipath interference, signals bouncing off cliffs and ridges, frequency modulation often coped far better. American tank units discovered that even when separated by hills and ravines, they could still maintain usable communication. As Shermans climbed the rocky approaches toward places like Cassino, their radios allowed platoons to coordinate movements that German doctrine claimed were impossible without direct visual contact. Tanks could cover one another through blind curves. Units could time their advances so that no vehicle was left unsupported in a narrow defile. German and Italian radios, heavily dependent on amplitude modulation and limited distribution, often faded into static in the same terrain. Crews were forced to rely on prearranged signals and guesswork. The American advantage was not absolute, but it was real, and it grew with every engagement. On June 6, 1944, as dawn broke over the coast of Normandy, Sherman tanks emerged from landing craft into a world of chaos. Waves crashed against steel hulls. Smoke from naval bombardments drifted low over the beaches. Ahead lay minefields, obstacles, and fortified positions. Yet even here, in one of the most complex operations in military history, radio networks held. Sherman commanders with SCR-08 sets could talk not only to each other, but also to naval fire support ships offshore. A tank that spotted a strong point could relay its position, and minutes later, shells from distant guns would crash down onto the target. This kind of coordination, armor on the sand, ships at sea, artillery firing far behind, would have been unthinkable without reliable communication. Radios did not eliminate confusion or danger. Many crews were lost in the attempt, but they allowed the invasion force to adapt on the fly, to exploit small successes and respond when plans inevitably changed on contact with reality. Yet even in this moment of success, American commanders discovered a serious flaw. The tank radios and the infantry radios were, in many cases, talking past each other, literally. The problem lay in frequency. Sherman tanks with SCR-508 sets operated between 20.0 and 27.9 MHz. The infantry's SCR-300 backpack radios used a higher band, 40.0 to 48.0 MHz. They were in effect speaking different technical languages. On the hedgerow line lanes of the bocage, this gap had painful consequences. German infantry teams armed with short-range anti-armor weapons could slip through gaps in the hedges, moving close to American tanks. Sometimes American foot soldiers saw the danger developing. They watched shadows move along high earthen banks, heard the rustle of movement in the brush. But they had no direct way to warn the tanks. They could shout and wave, but in the confined, noisy environment of the Sherman's interior, those signals were often missed. American crews felt that gap in the most personal way possible. A tank that advanced even a few meters ahead of its infantry escorts risked becoming a blind giant, powerful but unaware of danger only meters away. The solution, when it came, did not begin in a laboratory or an office. It began in the inventive minds of the crews themselves. Somewhere in Normandy, a crew welded an ammunition box to the rear of their Sherman. Inside, they mounted a simple EE-8 field telephone handset, connected by a cable that ran through the armor and tied into the tank's internal communication system. It was an improvised solution, crude but effective. Now an infantryman could run up behind the tank, lift the handset, and speak directly to the crew inside. "There's a threat in that barn. Hold position at the next crossroads. Enemy armor reported on the left." Within weeks, this field modification spread like wildfire. By the time of Operation Cobra in late July 1944, rear-mounted telephones had become a common and officially endorsed feature on many Sherman tanks. It was a small change in appearance, but a giant leap in coordination. For the first time, infantry on the ground and tank crews inside steel hulls could share a direct line of communication in the middle of battle. This simple idea, combining sophisticated radio networks with low-tech, practical interfaces, would dramatically improve cooperation and reduce unnecessary losses. It was another reminder that technology alone is not enough. It must be shaped by the experience and creativity of those who rely on it. Operation Cobra, launched from July 25th to 30th, 1944, would showcase what happened when these innovations came together. The 2nd Armored Division, under Major General Edward H. Brooks, unleashed more than 200 Sherman tanks into a carefully prepared breakout from the Normandy hedgerows. Above them, aircraft pounded German defenses. Behind them, artillery stood ready to respond at a moment's notice. At the center of this storm was a web of radio communications. Tank platoons spoke to their company commanders. Commanders coordinated with artillery observers and liaison officers. Units shifted directions based on reports from tanks that were miles apart. German defenders from the Panzer Lehr Division, once one of Germany's elite armored formations, found themselves facing an enemy whose movements seemed uncanny. American tanks reacted to threats before they were fully apparent. Artillery fell on assembly areas before attacks could properly form. It was not that every decision was perfect or that mistakes vanished. Far from it. But American units could adapt with a speed that German doctrine had never anticipated. Where German forces often depended on rigid orders and limited communication, American armor flowed like a network, reconfiguring, reinforcing, and exploiting opportunities on the fly. Behind these battlefield successes stood a story of industry and meticulous engineering. Motorola's Chicago factory, once focused on car radios, had been transformed into a high-precision production center for military communication systems. Retooling meant more than just changing tools. It meant rethinking entire processes to meet the unforgiving requirements of war. Each SCR 5008 set consisted of approximately 2,748 individual components. The BC 604 transmitter alone contained hundreds of capacitors and resistors. Crystal oscillators had to hold their frequency despite heat, vibration, and sudden shocks. Power supplies had to smooth out the electrical noise created by the tank's own systems. In 1942, the United States produced around 3,800 radios in this family. In 1943, that number climbed to roughly 1,100. By 1944, it reached approximately 24,000 units. Total wartime production surpassed 50,000 tank radio sets. These numbers matter because they reflected a simple but profound fact. The United States was not just building tanks, it was building connections. By war's end, all 49 of 224 Sherman tanks produced had been equipped with sophisticated FM radio systems. No other nation came close to achieving this level of universal deployment. The contrast with German production was stark. In 1943, Germany built roughly 5,700 medium tanks, yet fewer than 2,000 FUG transceivers were produced that same year. Even elite units struggled to equip every vehicle with a full transmit and receive system. Many radios were diverted to command vehicles, assault guns, or other priorities. In practical terms, this meant that at best, perhaps 1 in 5 German tanks in many formations had complete radio capability. The rest depended on visual signals, prearranged orders, or simply following the leader. Soviet forces faced even greater challenges. The T-34, one of the most important tanks of the war, often rolled into combat without any radio at all during the early years. Soviet doctrine compensated with flag signals and carefully planned formations, but the lack of real-time communication came at a high cost. By 1943, Lend-Lease shipments began to change that picture. American radios, including SCR 508 sets, equipped some Soviet command tanks. Yet even by the end of the war, only about a quarter of Soviet tanks carried radios. While other nations struggled to provide basic communication to a fraction of their armored forces, the United States had quietly achieved something unprecedented. a fully connected fleet. The technical advantages of the SCR-508 system went far beyond its raw transmission power and production numbers. Crystal-controlled frequency stability allowed tank crews to preset channels before going into action. Once locked in, those frequencies stayed solid despite the shifting temperatures inside the vehicle or the violent jolts of rough terrain. German Fuji 5 radios, relying on variable capacitor tuning, demanded constant adjustment. In the heat of battle, with nerves high and seconds precious, even small drifts could mean the difference between a clear message and empty static. Inside the Sherman, the radio was seamlessly integrated with the BC-606 intercom system. Every crew member, from the driver hunched low over the controls to the gunner peering through his sights, could speak to the commander using throat microphones or noise-canceling headsets designed to cut through engine roar. In many German tanks, by contrast, internal communication relied on shouting, tapping, or physical contact. It worked, but only up to a point. Under heavy stress, with the world shaking and echoing around them, clarity suffered. In the American system, information flowed not just between tanks, but within them. A loader who glimpsed a threat through a vision slit could shout a warning into his microphone. Within a heartbeat, the commander could relay that information to the entire platoon. Power management was another often overlooked, but vital advantage. The SCR-508 system could operate on either 12 or 24 volts, automatically adjusting to the electrical system available in the tank. Its dedicated power supply filtered out much of the electrical noise generated by the vehicle itself, keeping communication channels as clean as possible. German radios, frequently drawing power directly from the main vehicle systems, were more vulnerable to interference. Every spark, every fluctuation in current could translate into a burst of static on the line. All of this supported a new kind of armored doctrine. American combat commands organized units into flexible task forces, mixing tanks, infantry, artillery, and support elements based on mission needs. This concept only worked because commanders could rely on their radios to keep these shifting formations coordinated. A tank from one battalion could join forces with infantry from another, supported by artillery observers attached temporarily for a specific mission. They might never have trained together before, but their radios spoke the same language and operated on compatible networks. To German commanders used to more rigid structures, this flexibility could be deeply unsettling. They were facing an opponent whose units seemed to combine and separate fluidly, trying new approaches on short notice without losing cohesion. One of the clearest demonstrations of this new way of fighting came in September 1944, during the Battle of Ericourt. The U.S. 4th Armored Division faced several German panzer brigades equipped with Panther tanks, vehicles that, on paper, outclassed the Sherman in armor and firepower. The German guns could engage at long range. Their frontal armor resisted many of the Sherman's standard rounds. Yet the battle did not play out according to the technical specifications. American crews used terrain, weather, and, crucially, communication to offset their disadvantages. Tanks that spotted German armor in the mist could report positions instantly. Tank destroyers waiting in ambush received precise directions from units that could not even see the target themselves. Artillery observers in specially equipped Shermans were able to bring down accurate fire within minutes of receiving reports. Over the course of about 3 weeks, the 4th Armored Division destroyed approximately 281 German armored vehicles, while losing about 41 Shermans. The exchange ratio, around 7-to-1, defied the expectations of anyone who judged the battle solely by armor thickness and gun caliber. Radios did not win the battle alone. Crew skill, leadership, and courage were essential, but communication gave those qualities room to shine. It allowed information to move faster than the enemy's ability to react. While American crews were learning to trust their networks, German intelligence officers were trying to understand what they were facing. Reports from the field repeatedly mentioned that American tank units demonstrated excellent radio discipline and coordination. Messages were concise, clear, and apparently well-structured. In one captured assessment from late 1944, German analysts concluded that this effectiveness was due to intensive training and strict procedures. They recognized the quality of American communication, but still failed to grasp the full significance of FM technology and universal radio deployment. They continued to target supposed command tanks, vehicles with multiple antennas, assuming that destroying these would shatter American coordination. What they did not realize was that in many American units, every tank could take over command functions if needed, destroy one vehicle, and another would simply assume its role on the net. Again and again, German forces attempted ambushes based on assumptions that had once been accurate in their own formations, that cutting off leaders would paralyze the whole. But they were fighting an enemy whose structure was more resilient because the network itself was distributed. As the war in Europe neared its climax, the power of rapid communication became even more apparent. In March 1945, American forces approached the Rhine River, Germany's last great natural barrier. At the town of Remagen, units of the U.S. 9th Armored Division made a discovery that stunned them. The Ludendorff Bridge, a vital crossing point, was still standing. The moment this was confirmed, radio networks came alive. Messages raced from the forward units on the riverbank to higher headquarters. Within minutes, senior commanders knew that a rare opportunity had appeared. Orders flashed across multiple nets. Nearby units were redirected. Support elements shifted their routes. Within an hour, entire divisions were adjusting their plans to exploit a bridge that might collapse or be destroyed at any moment. German forces, dependent on telephone lines and more fragile communication infrastructure, struggled to respond with similar speed. Many of their lines had been cut by air attacks or artillery. Messages that might have taken minutes over radio sometimes required precious hours. In the end, the bridgehead at Remagen became a symbol not only of courage and quick thinking on the ground, but of the broader reality. American forces were operating inside an information environment that allowed them to act faster than their opponents. The encirclement of the Ruhr Pocket in April 1945 brought this communication gap into even sharper focus. American armored columns from the 1st and 9th Armies moved in a vast pincer, closing around hundreds of thousands of German troops. The operation required precise timing, careful coordination, and constant adjustments as units advanced along different axes. Radio networks stitched this complex maneuver together. Tank columns reported their progress. Reconnaissance units transmitted sightings of enemy movements. Artillery and air support were coordinated through forward observers equipped with reliable sets. Inside the pocket, German units struggled to maintain any cohesive picture of what was happening. Telephone lines were severed. Command posts were struck by air attack. Radio nets, limited in reach and density, could not reliably connect scattered formations. Field reports from the German side described units losing contact not just with higher headquarters, but even with adjacent formations. Messages became one-way, orders issued without confirmation, pleas for assistance that went unanswered because they never arrived. When the pocket finally collapsed, the numbers told one story. The silent channels and unanswered calls told another. A story of how isolation on the electromagnetic battlefield can be just as decisive as disadvantage in armor or ammunition. For the soldiers inside the vehicles, this was not just about strategy or technology, it was about how it felt to fight. American tank crews often spoke years later about the reassurance that came from knowing that, no matter how cut off they seemed physically, they were almost never alone on the net. A lone Sherman on a muddy road at night could still hear the voices of other crews. A commander who found himself facing an unexpected threat could call for help. And even if assistance could not always arrive in time, he knew someone was listening. Someone understood his situation. On the German side, memoirs by tank commanders like Otto Carius describe moments of deep isolation, vehicles advancing in poor visibility, unsure of where neighboring units were, receiving only fragmentary information about the broader situation. They fought bravely, often with remarkable skill, but they did so within a communication framework that limited their ability to share what they knew. The psychological impact of this difference was profound. Connection builds confidence and allows leaders to take calculated risks. Isolation breeds caution and, at times, a sense of being left behind by events moving faster than information can travel. In the long run, this human dimension mattered as much as any technical specification. After Germany's surrender, American and Allied technical intelligence teams examined captured equipment and documents. Their reports confirmed what many crews had sensed during the fighting. German tanks often possessed excellent guns and strong armor, but their communications technology lagged behind by several crucial years. One U.S. technical intelligence report estimated that German tank radios were roughly 5 years behind American systems in terms of key capabilities. The lack of frequency modulation, the limited deployment of full transceivers, and the difficulty of suppressing electrical interference combined to create a serious vulnerability. Soviet evaluators given access to captured German equipment after the war reached similar conclusions. When they looked to improve their own communication systems, they often chose to emulate American designs rather than German ones. The lesson was clear. It was not enough to build powerful individual vehicles. Power had to be supported by information, by the ability to coordinate, to share, and to react together. In essence, the United States had not just built tanks. It had built a network and then put that network on tracks. The numbers, when placed side by side, tell their own quiet story. American SCR 508 family radios, more than 50,000 units produced. Sherman tanks, 49,324 built, each one receiving advanced radio equipment. Typical communication range on the move, around 7 miles. Stationary under favorable conditions, 10 to 15 miles. German Fugi 5 transceivers, roughly 6,000 produced, medium and heavy tanks around 12,000 built. Effective range on the move, often less than a mile in challenging conditions, sometimes only a few hundred meters. Artillery response times differed as well. American units able to relay target information quickly through multiple radio nets could often bring supporting fire onto a location within 3 to 5 minutes. German units relying more heavily on wired systems and less dense radio coverage frequently required 15 to 30 minutes or more to achieve comparable effects. Multiply these small advantages over thousands of engagements, and they become something enormous. Faster information meant faster decisions. Faster decisions meant the ability to seize fleeting opportunities or to avoid disasters that might otherwise have unfolded in slow motion. The principles established by the SCR 508 did not vanish with the last Sherman rolling off the line. They became the foundation for modern armored communication. In the decades after the war, the newly formed Bundeswehr, the armed forces of West Germany, took these lessons to heart. Their Leopard tanks were designed from the beginning to carry comprehensive, reliable radio suites. Training manuals explicitly emphasize coordination and communication, shaped by hard memories of what had been lost due to earlier limitations. Around the world, armored doctrine shifted. Radios were no longer seen as optional equipment for selected vehicles. They became central nervous systems for entire formations. The idea that every tank should both hear and speak, that networks should be robust and redundant, became standard practice. Technologically, later systems moved from analog to digital, from single-channel sets to complex, encrypted, multi-band suites. But the core idea remained unchanged. In modern warfare, the side that can share accurate information quickly has a decisive edge. In many ways, this revolution began not in the 1970s or 1980s, but in the 1940s. Inside Sherman tanks carrying noisy, glowing valve-based radios across deserts, mountains, hedgerows, and river crossings. Modern conflicts have only reinforced this truth. In 1991, during the Gulf War, coalition forces equipped with advanced communication systems faced Iraqi units operating Soviet-designed tanks that were, in some cases, formidable on paper. Yet the coalition's ability to share targeting information, coordinate air and land assets, and maintain a coherent picture of the battlefield proved decisive. Again in 2003, during operations in Iraq, American and Allied units demonstrated how network forces could outmaneuver opponents who relied more heavily on local initiative without the same level of informational support. In each case, the principle that mattered most was not simply who had the largest gun or the thickest armor. It was who understood the battlefield more clearly and could act on that understanding more quickly. The Sherman, with its SCR 508 radio set, was not a perfect tank. It had vulnerabilities and limitations. Veterans who served in them knew that better than anyone. Yet, together with its radio, it represented an early example of something far bigger, a system in which each vehicle was a part of a larger intelligence, a shared awareness that extended beyond any single crew's field of view. Looking back, some historians have suggested that this was one of World War II's quiet revolutions, a shift less visible than new tanks or aircraft, but just as important. German officers at the end of the war reportedly reflected on this difference with a mixture of respect and regret. One statement often attributed, whether precisely quoted or not, captures the essence of their realization. We knew how to build powerful tanks. You knew how to make them work together. That is the heart of the story. The United States did not simply produce 49,324 Sherman tanks. It produced 49,324 connected platforms, nodes in an armored network spanning continents. For the veterans who served in those vehicles, the most vivid memories are not of technical specifications, but of lived experience. The scratchy but understandable voice in their headphones, the quick confirmation of an artillery mission, the warning from another crew that saved them from an unseen threat. In honoring them, we are also honoring the engineers, radio operators, line workers, and mechanics who made that communication possible. People whose work rarely appears in dramatic photographs, but whose contributions shape the outcome of the largest conflict in human history. And so we return to that morning near Kasserine Pass. To a German tank commander watching, puzzled and uneasy, as a group of Shermans moved in ways his training did not fully explain. To American crews inside those tanks, listening to steady voices through their headsets as dust and smoke swallowed the horizon. Much of what happened that day looked, to an outside observer, like instinct or luck. Tanks turning at just the right moment, appearing from unexpected angles, reinforcing each other when it mattered most. But beneath those movements lay countless unseen decisions, messages sent and received, warnings heeded, orders adapted in real time. Each short phrase over the radio condensed experience, training, and judgment into something crews could act on immediately. The invisible lines that connected those tanks across broken ground were as real and in many ways as powerful as any armor plate or shell. They were part of a new battlefield, one made of information as much as iron. For the men inside those vehicles, the war was not a set of statistics. It was a series of days and nights, of long marches and brief, intense engagements. It was the exhaustion of endless maintenance, the tension of waiting for an unseen threat, the relief of hearing a friendly voice at just the right moment. Veterans who served in Shermans sometimes describe the radio not just as a tool, but as a lifeline. It gave structure to confusion. It allowed leaders to explain, reassure, and sometimes simply let their crews know that the larger plan still existed, even when things looked uncertain from inside a cramped fighting compartment. Many of those veterans are no longer with us. Their stories, however, live on. In memoirs, in interviews, and in quiet conversations with families, they have passed down memories of what it meant to fight in a tank that was not truly alone. Their experiences remind us that warfare is ultimately human. Technology shapes what's possible, but it is people, crews, commanders, engineers, operators who decide how that technology will be used. Today, when modern armored crews step into vehicles filled with digital displays, encrypted radios, satellite links, and complex data networks, they are inheriting a tradition that reaches back to those early glowing dials and heavy steel cabinets. The idea that connection equals survival was born in moments like the ones we have explored, on dusty tracks in North Africa, in narrow Italian valleys, in the hedgerows of Normandy, on the banks of the Rhine, and in the closing ring around the Ruhr. The SCR-508 did not look like the sleek electronics of today. It hummed, it warmed the air, it required careful tuning and constant maintenance. But it embodied a principle that has only grown more important, that information, shared quickly and clearly, can be as decisive as any physical weapon. The Sherman tank's legacy is not just one of steel, it is one of voices. Voices carried across miles, across confusion, across fear. Voices that turned many individual vehicles into a single, coordinated force. In the end, German troops across 3 continents discovered a hard truth. They were not just facing more tanks, or more factories, or more supplies. They were facing an opponent that had quietly mastered a new dimension of warfare. American Shermans did not win every battle. Crews bore heavy losses and endured long, difficult campaigns. Yet time and again, their ability to coordinate, to act as one rather than as isolated individuals, shifted the balance. When we remember that era, we often picture the silhouettes of tanks against the horizon, the thunder of engines, the tracks chewing through mud and sand. But behind those images lies an invisible story, the hum of a transmitter warming up, the click of a channel selector, the first clear word coming through a headset. That sound, the sound of connection, helped shape the outcome of World War II. And long after the last Sherman rolled into history, the lessons it taught about communication, coordination, and shared awareness continue to guide the armored forces of the world.